Hello everyone. In this session, we will discuss arithmetic progressions. In previous session, we discussed sequence and series. Two special type of sequences are arithmetic progression and geometric progression. In this session, we'll focus on arithmetic progression. So next comes the question, what is arithmetic progression and when can we say that the numbers are in arithmetic progression? So let us define that. A sequence of numbers are said to be in arithmetic progression when the difference between any term and its preceding term is a constant. Let us understand this definition by considering one simple example. Say we have a collection of numbers 1, 3, 5, 7, 9. If you observe here, the difference between second and first term, that is 3 minus 1, which is equals to 2. Similarly, difference between third and second term, that is 5 minus 3, that is 2. And fourth and third term, that is 7 minus 5, that is equals to 2. Similarly, fifth and fourth term, that is 9 minus 7 is equals to 2. So when the difference between the term and its preceding term is a constant, we can say that the sequence is arithmetic progression, right? Or in other words, by adding a constant number to the term, we are able to get the next term. So we can say that the sequence is arithmetic progression. So in this particular example, 1 plus 2 results 3 and 3 plus 2 is 5. 5 plus 2 is 7. So here the constant term 2 is added to the term to get the next term. So we can say that these numbers are in arithmetic progression. In arithmetic progression, the first term is denoted by letter A and the difference between the term and its preceding term is called common difference and it is denoted with the letter D. So in this particular example, A, that is the first term, is equals to 1 and common difference D is equals to 2. Now let's see how to represent arithmetic progression in general. Now we know that first term of an AP is represented with the letter A and common difference is represented with the letter D. Let us see how to represent nth term of an AP. So the first term, which we represent it as T1, is nothing but A, or we can also represent it as A plus 1 minus 1 into D. Right? Here 1 minus 1 is nothing but 0. 0 into D is 0 only. So we will get A. So the second term, similarly we can represent it as second term is nothing but by adding D to the first term, we will get the second term. Right? That is A plus D. Or we can write it as A plus 1, we can write it as 2 minus 1 into D. So that the resulting number is A plus D. Similarly, the third term is nothing but adding D to the second term, that is A plus 2D, or we can represent it as A plus 3 minus 1 into D. Now next comes the question, why to represent A as A plus 1 minus 1 into D and T2, that is second term A plus D, as A plus 2 minus 1 into D. We are representing like this so that we can derive general term, that is nth term of an AP. Right? In order to obtain the general term, we are representing A plus 2D as A plus 3 minus 1 into D. Similarly, fourth term A plus 3D, we can write it as A plus 3 is nothing but 4 minus 1 into D. So from these representations, we can write the nth term, that is Tn, as A plus, here in place of n we are considering as n minus 1. So here to take it as n minus 1 into D. This is called nth term of an AP. If we know first term and the difference between the terms and nth term, we can calculate Tn. n, right? Let us see how to find out sum of n terms of an AP. Now we know that first term T1 is nothing but A, and last term, or else I can represent it as L, is nothing but A plus n minus 1 into D. Now I want to find out sum of n terms. Let us represent the sum as Sn. So this will be equals to n by 2, that is how many terms we are considering, into A plus L. This formula is useful when the first term and the last term of an AP are given. Or else we can also represent it as sum of n terms as n by 2 into A plus, as we know that L is nothing but A plus n minus 1 into D. Or we can write it as n by 2 into 2A plus n minus 1 into D. These formulas are useful to find out sum of the terms in a sequence. In next session, we'll discuss properties of arithmetic progression. Please subscribe to our channel for latest updates. Thank you for listening and have a nice day.